Welcome to the webinar, Object Storage, using Next Generation Storage to solve today's data problems. Before we begin, let's review some housekeeping items. If you have any questions during the webinar, please type them into the questions control panel. We will try to answer all questions at the end of the webinar during the Q&A portion. All right, so let's begin. I'd like to kick off the webinar by introducing our speaker for today. We have Adrian Herrera, the VP of Marketing at Caringo. Welcome, Adrian, and thanks for joining us today.
Thanks for the introduction, Jeff.
Sure.
And I guess I will go ahead and get started. First of all, thanks everyone for attending. This is a pretty short session, 30 minutes. We have a lot of information to cover. So as Jeff mentioned, just type in your questions. If possible, if I see them throughout the presentation, I'll try to answer them. If not, we'll leave some time at the end for Q&A. So with that, let's get started. So here's a brief agenda. So we're going to go over the enterprise storage market, some of the changing trends that we're seeing, some of the business issues that a lot of our customers are experiencing. We're going to go over 3 trending use cases. And then at the end, we'll let you know how to get in touch with us so that if you are interested in evaluating object storage or just asking questions, we can be your resource and your source of information. So, first slide, expectations of storage have changed. So we're seeing, it's not only data growth that's causing this interest in object storage and software-defined storage, but it's the rate and the velocity of data growth. So depending on which analysts you believe, data is anywhere between 7 to 40 zettabytes in total. That's just a massive amount. One analyst in particular that we follow has said that 90% of the information was created in the last 2 years. That's just a really rapid pace of data growth. And most of this data is unstructured. So your audio files, your video files, photos. Compounding this issue is this expectations for users to create and access data wherever they are. And we like to call this cloud conditioning. They're used to just picking up their iPhone or picking up their laptop and wherever they are and accessing all the information that they've created. And if IT can't provide that internally, they can just go to Dropbox or any other service out there, drop their credit card down and get that functionality from somewhere else. That leads to a pretty major security risk for some organizations. And adding yet another layer of complexity is this notion of time. Users want their information when they want it, regardless of when they created it. It's a very difficult challenge for storage administrators, IT administrators, and increasingly for developers. We're seeing a lot of developers that need to keep their users or their customers' data online and accessible in perpetuity. The days of putting something on tape if it hasn't been used in the last 30 days and relegating it to the salt mines are pretty much gone or fading away now. So what is leading to this data growth? You usually see the big hockey stick graph, and a lot of it is corporate information, and they never really go into, okay, what's leading the data growth. And I really like this chart because it's a little non-traditional, and it lets you know what goes on in an internet minute. And I know it's hard to see here, but if you do a quick Google search on an internet minute and fresh infos, this infographic will pop up. And a lot of these companies just weren't around in 10 years ago. And just think about your storage infrastructure in your data center. Even some of these companies weren't even around 5 years ago. So if you go and you look, or they weren't popular 5 years ago, if you go and you look in your data center, do you have 5-year-old technology? Chances are you probably do. Look at Instagram's growth in 1 year. 76% more photos were uploaded per minute. That's per minute. If you take a look, Vine was only founded in 2013. And this is all user data, but there's a lot going on behind the scenes. this information that's created by users is creating demographic information, it's creating log files, it's creating advertising, and all of that is corporate information, business information. So the nature of enterprise data and data access patterns are changing. This is driving the increase in unstructured data growth. Now, the question is, how do you store all this information? So let's take a look at your network storage options. So there on the left, you have block, in the middle, you have file, on the right, you have object. So from the block perspective, block data is organized as an array of blocks. You carve out a portion of these blocks to form a volume that can be formatted as a local block device. Access for block storage is usually through a client on the operating system over Fibre Channel or iSCSI. Fixed system attributes are stored with the block. Block storage is really ideal for transactional or structured information like databases, running VMs, and is optimized for performance or IOPS, output operations per second. Now, file, you see the little forks up there are really directories, and file-based storage is usually accessed via standard storage protocols like NFS or SMB. These are traditional storage protocols that were really developed to ease the sharing of files and information over the network. Fixed file attributes like type, size, date created, date modified are all stored in the file system. So file-based storage is good at shared files and shared directories over LAN or WAN. There are some cloud-based file system services emerging like Amazon Elastic File System and OpenStack Manila, but they're still relatively expensive or still in development. Now let's take a look at object storage. And you can see already just by the schematic the simplicity in access there. There we go. So object storage is based on key value addressing. It's very similar to you parking a car at a valet. You take your car, you give it to the valet, and they give you a ticket, and you don't really care where they park it, just as long as you can get it back when you get that ticket. That's really what you're seeing there in the top graphic. The client or access method is usually an application over HTTP, and system or custom information about the file is stored in metadata. So object is ideal for shared or infrequently changing files or for scalable, massively scalable multi-site deployments. And I want to say, infrequently changing files may not be the right characteristics. You can have moderately frequently changing information and still use object storage to store it. So object storage is not good for all data, for storing all data like transactional, high transactional applications or databases, but it's good for most information that's created today. And one thing that's important to see here, I didn't really position these as devices. I will in a bit, but what we're saying is these are really now becoming interfaces, block interfaces, file interfaces, and object interfaces, all on top of different types of methodologies. So there are some object storage solutions out there that support all of these types of interfaces. Similarly, there's file system-based solutions that support these interfaces. So these are really the protocols of the interfaces that interact with your applications that ultimately store the information. So now that we've established the network technologies, let's take a look at some of the business issues that are driving the changing landscape of enterprise data. And the first is the exponential growth of data. I mentioned the traditional hockey puck. Here it is. And the red section there are IT storage budgets. So IT storage budgets just are not growing at the same rate of your data growth internally. And that's leading to some pretty interesting challenges. So what was done just a few years ago simply won't work. Hold on, I gotta go back. Simply won't work in now, really. We're seeing IT budgets being stressed. We're seeing resources. It's not just the capital cost of hardware. It's the operational resources to manage the data growth, along with all of the additional requirements that users expect, being able to access information from anywhere, being able to get it whenever they want it. So the second business issue is cost and productivity. So on the left-hand side, you have capacity. At the bottom, you have price, and on the right-hand side, you have access requirements. So you can see where object storage fits in from a capacity, cost, and access perspective versus SAN and NAS. From a cost perspective, SAN is roughly around $2 to $3 per gigabyte. NAS is around $1 per gigabyte. And objects can go well under 20 cents per gigabyte. Again, these are just rough figures. Most analysts will agree that the lion's share of growth is happening in unstructured data, and that most of this data needs to remain accessible and searchable to drive not only business agility, but productivity. This is where the new opportunity for object is. Right there, encompassing NAS and object. If you want reliable, scalable storage over a petabyte that's instantly searchable, then object storage is really, the only practical way. Now, let's take a look at the effect of software defined. So as you see, object storage is increasing in the software defined world. All prices are shifting to the right because of the use of commodity hardware. In addition, the market for traditional NAS appliances is eroding because of software NAS options. Object storage is also chipping away at NAS use cases, as we'll see later in the presentation, because object storage software is so adaptable, you can use commodity hardware with higher performance characteristics with file interfaces, as I mentioned before, to meet a subset of traditional NAS workloads. Actually, it's a very large set of traditional NAS workloads. That's an important point to drive home, that you can use object storage or software-defined storage on higher performance hardware and tune to a particular use case. We're also seeing improved productivity. So as we saw on the previous graph, the overall opportunity to use object in the data center is increasing, ultimately making your IT budget go a lot farther, while increasing business agility and overall productivity. Now, let's take a look at the third business risk, or I should say third business issue, and that's risk. And risk is really a combination of a lot of different things. And this is what we hear, this isn't an exhaustive list, but this is what we hear from a lot of our customers, that they have too many files. And when they say they have too many files, what they're really saying is they just don't know what's being stored on the storage that they're providing to their organization. People put stuff in weird places and weird directories. Sometimes, the files, there's a high employee turnover rate. So there's also wasted budget. So legacy storage technologies are rather expensive when compared to a lot of current commodity-based solutions. It's around the comparison between object storage and NAS, depending on the prices you're getting, is around 4x, and can increase all the way to 10x depending on the NAS and the object storage solutions. You also have limited reuse. So in NAS and SANs, data is siloed for the most part. You have a finite capacity. You store your information in that finite capacity, and that information usually lives in a scale-up solution within a data center. So if you do want to combine data solutions, or if you want to combine data, consolidate data, and analyze across various data sets, it becomes difficult to do. Protection is also an issue. As drive sizes increase, RAID is really reaching its limits. Protection, backup applications are expensive and difficult to manage. all of this is, this complex, tedious management. Legacy technologies take constant care, constant reprovisioning, complex clustering. This is a challenge for storage experts, but a lot of IT staff with general knowledge are now needing to manage hundreds of terabytes to petabytes of information. And what we're seeing also is a trend of developers needing to manage storage. And a lot of the times developers aren't storage experts. They're your application experts, but they rely on storage as a foundation for their applications. So tedious and complex management of storage systems is just really hindering growth and flexibility in what they can do with their applications. And then you also have limited scale. So, file systems are getting better at increasing scale, but you do have some finite scale limits, not only in capacity, but also in overall file count. Now let's take a look at software-defined. So, this is just the definition of software-defined storage. You could go, look up on Google, do a Google search on software-defined storage, and the market's really beginning to agree on some definition of software-defined storage. So commodity hardware, providing end-to-end services, providing multiple interfaces and hardware forms, and also being fault tolerant. So there's a quote from IDC that says software-defined storage is here to stay. Such solutions are a core part of the scale-out solutions leveraging distributed data storage. So up there in the white are all the different types of software-defined storage that are out in the market, but not all software-defined storage solutions are the same. So here, I'll mention how we do things at Caringo. So you mentioned, or you saw on the previous slide, I mentioned commodity hardware. We do scale out on commodity hardware virtual machines, but we do it a little differently. We really focus on removing complexity wherever possible. You can mix and match standard hardware and capacity. There's rapid bare metal deployment. Everything is self-managing. There's no downtime for upgrades, and we don't have a file system. We're true object storage at the core. And you can scale by the drive if you'd like. So we offer storage that really adapts to your business. So fault tolerance, we also do this a little differently. So, we offer, bulletproof storage that can really be configured to provide 100% uptime. We have dynamic protection, so you can shift from replication to erasure coding. And you can do this all automatically via what we call life points that are stored in metadata. So it's complete automated data management within the solution. And we also provide end-to-end data services, or the ability to provide end-to-end data services. Again, going back to the definition of software-defined storage. So we provide linear scale out of capacity and throughput. The thing to point out there is the encapsulated metadata with ad hoc search and query. This is really where the future is going. The ability to not only store information and access it over the web, but also make it actionable. Search against it, save those searches, and make those searches dynamic. And if we're going to be coming out with some very exciting product enhancements in the very near future. And if you're interested in being part of the launch or being notified of the launch, just go ahead and email me after the webinar. So those are just the technical differentiators, why organizations are using Caringo and how we fit into or how we apply the software-defined concepts, object storage concepts, differently than others. And here are some trending use cases that we're seeing. So this is one of our largest customers. It's the Department of Defense. It's a medical imaging use case. It's really interesting where they are taking medical images out in the field. They're storing them on servers, bringing them back into a main cluster and just plugging those servers in, and they automatically add to the cluster. So it's a way to efficiently move very large files from somewhere where there is limited or unreliable bandwidth back into the main archive. They require file governance and long-time investment protection and durability. They have hundreds of sites geographically, and the archive is facilitated by a vendor-neutral archive. So the trend there is really eliminating storage silos. This would have been very difficult to do with NAS and SAN, and the value is really through the accessibility and the flexibility of the architecture and being able to store something in one location and easily bring it back into the main archive. And of course, everything has to be very cost-effective and reliable. You're storing medical images that are often used in providing healthcare or during operations. So you need to make sure that that data is going to be there when you call upon it. Another trending use case we're seeing is the use of big data, of course, analysis, Splunk, and Hadoop. So this, we can't mention who this customer is, but it's a very large service provider. They're using Splunk for log file analysis. They store log files ranging from 1 to 100 megabytes in size, and they need to ensure that those are instantly searchable over 2 years. And they need to be able to store those in 2 separate sites that are over 1,000 miles apart. One of the challenges they had was moving data off of NAS and onto Swarm. There were some issues with the NAS they were using, and they needed to scale over 2 petabytes per location. It was really a capacity issue. And the trend here is instant analysis with stringent retention requirements. So Swarm beat out all other object players because it was bulletproof. They ran us through the ringer. They did stuff like pull network cables. They ripped out drives. They even ripped out one drive and put it in a separate chassis. And with every test that they put us through, we passed with flying colors. So it's this notion of not only being able to provide search and analysis, but being able to provide it in an incredibly reliable way that always has data integrity in mind. And then the third use case we're seeing, trending use cases for cloud storage. So a trend that we're seeing is rapidly deployable cloud storage worldwide. This isn't only for service providers like BT, although we too provide this for service providers like BT, Telefonica, and others. Global organizations also have this need to be able to rapidly deploy storage, reliable storage that's accessible over the web, that's accessible over or from any application globally, worldwide. And the reason is, a lot of different countries obviously have different governance and regulation requirements. So the way to abide by those is to store information within country borders. And that's exactly what BT does. So they have many different data centers worldwide, and they have multiple clusters within those data centers. They provide various degrees of SLA, and you can do that with our software, with object storage. And they provide end-to-end security, performance, and reliability. And here's a quote by the CTO of Cloud Services, John Gillum from BT, that he gave when he was being interviewed by TechTarget. And it says, scalability is one of the slickest things about Caringo. One sweet thing they did with the platform is when you drop a new node in, it builds itself from the ground up. So regardless if you need a terabyte or a petabyte, you just drop in the new hardware. You don't have to mess with provisioning. You don't have to mess with installing operating systems and patching. It boots from bare metal, and it'll add to the cluster. So kind of wrapping all of this up is, solving today's storage issues with object storage. We go back to the issues that were presented, the too many files. So with object storage, with software-defined storage, you can consolidate files. There's this notion of wasted budget with traditional storage technologies. You can reduce storage TCO. Your level or magnitude or rate of reduction will depend on the prices you're getting, the hardware you're getting. But typically you can experience anywhere between 50% to 75% savings. Limited reuse is fixed by providing secure, scalable search and analysis really from anywhere. The issue of protection is solved by streamlining backups and recovery and offering continuous protection. Didn't really go into replication and erasure coding in this webinar because we don't have time, but we have a lot of great information on replication and erasure coding and best practices on our website. Tedious management is solved by really relying on automation internally. Not only automation of the management of the objects on the object storage solution, but also management of file tiering from traditional filers. So when you do go and you evaluate other object storage solutions, take a look at whether they provide just a simple file system interface or whether they provide technology that helps you manage transfer of information to and from filers. We do that. We have a product called FileFly, and it's fully integrated with Swarm. It works with NetApp filers and Windows file servers. And then the issue of limited scale. Object storage, if you've done research, if you're on this webinar, chances are you have a scale issue. You're running out of space. You're trying to figure out how cloud storage service providers store their information. It really is with object storage. You can scale to hundreds of petabytes, even exabytes of capacity, trillions of files. Most object storage solutions do have linear scale of capacity and throughput, but it's not just about the ability to scale, it's how they scale. So in your evaluation, make sure that it's easy to install, deploy, and expand, because if it's difficult to do when you first start, it's going to be very difficult to do at scale. And all of this is provided ensuring data integrity, organization, and analysis at scale. Again, a few things to look for would be, automation, how much automation is in the solution, and search. Being able to search metadata, even being able to search different file system attributes. So again, I know I covered a lot of information, and I see that there are some questions that have come in. So I will take those one by one.